Welcome, class. In this video, we will learn our final method of factoring or solving for x. It is the quadratic formula. The quadratic formula will be used in any quadratic equation. Normally, we use the binomial factoring because it is much easier, but sometimes we have no choice but to use the quadratic formula. I have one example here. F of x equals x squared minus 2x minus 3. And we're going to first be finding the axis of symmetry, and then we will factoring it, and then we can graph it by adding a few points. But then we're also going to solve this equation using the quadratic formula afterwards, just to show that we get the same answers. So for the first equation, here we go. We know there's values for a, b, and c. A is 1, B is -2, C is -3. For graphing purposes, we can find the axis of symmetry using x equals -b over 2a. And here I plugged in the b value and the a value. Once we plug it in, we find x equals 1 is the axis of symmetry. Now, just as a reminder, when we have the graph, x equals 1 would just be the vertical line passing through the vertex. This would be the x equals 1 vertical line. To get the actual point of the vertex, we plug the x equals 1 value back into the original equation right here. And so we get a value of -4. So the actual vertex here is 1, -4. And the graph opens upward because it's a positive x squared graph. If we go back and look here, the value is positive. It's a positive 1. So the graph opens upward. So this graph obviously has a minimum at the vertex, a minimum. And the minimum value is -4. Now we're going to solve this equation and find where the graph crosses the x-axis. So if we look at the equation here, we have x squared minus 2x minus 3 equals 0. We can factor the equation as x minus 3 and x plus 1. We solve using the zero product property, and we get x is equal to 3 and x is equal to -1. Because these are x-intercepts or solutions, these points are 3, 0, and -1, 0. Now to graph the quadratic, we'll make a table of values near the axis of symmetry of x equals 1, and we'll plug in a couple more points. I also found the y-intercept here by plugging in 0 for x, and we got the y value to be -3. So this is the y-intercept, which is, of course, 0, -3. And here's the graph. I just graphed this on Desmos, the graphing calculator on the internet. We have the vertex, the y-intercept, the two x-intercepts, where they cross the x-axis at -1 and 3. And we added another point here, right here, from the table of values where we plugged in 2 and we got -3 as a point. Now we're going to use the quadratic formula. Now all these notes, the transcript of these notes are available in the Microsoft Word document that is attached with this video. Now the quadratic formula must be used from an equation written in standard form, ax squared plus bx plus c. The quadratic formula is x equals -b plus or minus b squared minus 4ac over 2a. And in another lesson, we're going to discuss the importance of this part of the quadratic formula. This part here is called the discriminant. And in another video, we're going to go over the significance of this discriminant value. It is actually very important. Now, the original function was f of x equals x squared minus 2x minus 3, where a is 1, b is -2, and c is -3. I plugged in the points, as you can see here in red. And we just did the math. And it all simplified in the n inside the discriminant to 16. So we have 2 plus or minus the square root of 16 over 2. We can take the square root of 16, which is 4, and there is always a plus or minus in front of the square root. And we get two values. We get 2 plus 4 over 2 and 2 minus 4 over 2. And I should have said or. These are the two answers, really. X equals two different values here. 3 and negative 1. Now, these are the same x-intercepts we got earlier. If we go back to the graph, 3 and negative 1, if we go back, here's the 3, and here's the negative 1 right here. So we got the exact same x-intercepts. Now, to finish the graph, I would still use the table of values if we had not done so already. And of course, always find the vertex. And just a little hint here, or excuse me, helpful note, whenever you have two x-intercepts, the vertex is always in the middle. The midpoint between minus 1 and 3 is going to be positive 1. If we did minus 1 and 3, we find an average of the two x-intercepts, and we divide by 2, we're going to get 2 over 2, which is 1. And that was also the axis of symmetry, because the vertex is always located between the two x-intercepts. Now let's look at another example here. Again, this is in your notes. We have another equation, 3x squared minus 7x plus 2. You always want to first identify the a, the b, and the c value, and then we just plug it into the formula. We have a negative 7, which is a plus 7. We have a b squared, which is a negative 7 squared, which is, of course, going to be the 49. And we have minus 4 times 3 times 2, because the a and the c are both positive values. So we get 49 minus 24, which becomes 25. 7 plus or minus the square root of 5 over 6. And again, we have two values here, as you can see in the arrows. And we get x is equal to 2 and x equals 1/3. These are the two x-intercepts. Now I wrote, because the answers in the first and second example comes out to nice rational numbers, these problems could be factored normally. Just like we factored the first problem, this second example could also have been factored. But there's times when we must use the quadratic formula. And I did an example problem here. F of x equals x squared minus x minus 3. This problem is not factorable. We cannot factor this. There are no two numbers that'll work. You will not get this equation up here. That is impossible. But the graph does cross the x-axis, so it does have x-intercepts, solutions, or zeros. Same thing. We can find where it crosses using a quadratic formula. We identify the a, the b, and the c values. A is 1, b is negative 1, c is negative 3. And we just plugged it in here. As you can see, I plugged in the values. And it simplifies to 1 plus or minus the square root of 13 over 2. The square root of 13 is prime, so we need a calculator to get the value of the square root of 13, which I did here, and I got it to be about 3.6. So we can do 1 plus 3.6 divided by 2 and 1 minus 3.6. And we get two answers, and they're both decimals, and they're both irrational because we actually rounded. An irrational answer is when we have a number, some sort of a decimal, that cannot be written as a fraction. 2.3 is not the actual answer. It's a rounded answer. And there's no fraction that can represent it. There's no fraction that can represent the actual answer. So we call it irrational. We just rounded to one decimal place here, or I did, just to show, because I made up this example here. Now I graphed the equation again in Desmos, and you can see the two x-intercepts of negative 1.3 and about 2.3. If we clicked on it, the graphing calculator actually gives me to about 4 or 5 decimal places. And you'll see that there's no pattern to the decimals. See, with regular factoring, you would never get these kind of values. The problem comes out prime, but the graph actually had solutions. But the factoring would tell you there's no way to get the solution. This is why the quadratic formula is used. Well, this concludes this video.